Hey, chemistry students, welcome to the final day of Unit 4. I am not going to talk very long so you can have a chance to work on your Unit 4 review problems today, but I did want to speak with you about the Unit 4 test, and I'm going to write some things down on this Google Doc as we go. First, the test is 5 pages long, and it is very complete. Completes in that it will cover 4A through 4C with some multiple choice, some short answer, some graph reading, about 5 different math problems, and a big lab question. So let's talk about each page. Page 1 is 10 multiple choice questions from everywhere in this unit. Page 2 is 9 multiple choice questions. Page 3 will be 2 multiple choice. I forgot to mention on page 2 you have some heating curve questions, and there will be a heating curve diagram picture on the test for the last 2 or 3 questions. But page 3, 2 multiple choice and 3 short answers. Page 4 will be 1 short answer and 3 specific heat math problems. Page 5 will be 1 specific heat math problem, and then the rest of the page is a marshmallow lab data set of questions. So there is the general setup. Let's go backwards a little bit. And first, 4A. Well, first of all, reminder, Thermochemistry is the title of the unit. And 4A was heavy in vocab. So a lot of introductory vocab. Just some examples off the top of the head. Heat, energy, specific heat, temperature, and average kinetic energy, plus others. Then the main focus was the specific heat equation. You should know how to solve for Q. You should know how to solve for CP. You should know how to solve for final temp. And remember, the equation is Q equals CP M delta T. And remember, that's all multiplication. So CP times M times delta T. You should also have written down on your green sheet already, because I let you, that CP equals Q over M times delta T. And then remember, when you solve for the final temp, you've got to algebraically turn delta T into TF minus TI. And then use algebra to get TF by itself. And I showed you that algebra several times. So, like I said, you're going to have at least 4 of those types of questions on this test. You'll have at least 1 or 2 within the multiple choice section also. 4B was very simple. The KMT, the kinetic molecular theory. So you should go back and familiarize yourself with the 5 assumptions of the KMT, especially going back and looking at what the word elastic means, and the just the overall gist, the constant movement of gas particles in those 5 assumptions. And then we finished with the properties of gases in 4B. So you should know expansion, compression, diffusion, amongst those properties. Remember, expansion is getting the particles getting farther apart. Compression is the gas particles getting closer together. And diffusion is defined as the movement of particles from high to low. So you have a whole bunch of particles in one area. Due to their quick movements, they will spread out within a room, within a container, on Earth, the law of diffusion. 4C. So, before I go 4C, there will be a handful of kinetic molecular theory questions within the multiple choice, and at least 1 short answer, maybe 2, will involve the KMT. 4C. States and state changes. So, this, you have to be able to define the difference, between a solid, a liquid, and a gas. Now we know solids are definite volume and definite shape. Liquids are indefinite shape and definite volume. Gases are indefinite shapes and indefinite volumes, but you should also know the arrangement of particles within those 3 states. So solids tightly packed and vibrating, liquids kind of tightly packed and moving as fluids, gas particles spread apart big distances and moving quickly. We applied liquids to the KMT also, and compared those to gases in that the liquids are slower moving, they're more dense, all due to their particle movements. We, on just one slide, said solids are not moving as much, their vibrations. State changes, you should know all 6 state changes and whether they're endothermic or exothermic. So you should know what they are and what they do. So we can go through those really quick. Freezing is exo. I'll do the 3 exos first. So you have to slow down the particles. You take energy out to slow down the particles. Condensation. And remember, freezing is from a liquid to a solid. Condensation is from a gas to a liquid, and you have to take energy out for that to slow the particles down. And finally, deposition. Is going from a gas to a solid, and that's exothermic also. And our example for that was freezing fog. So those are those 3 exos. The 3 endos, you have to put energy into to speed up the particles. Melting. So going from a solid to a liquid is endothermic. So you speed the particles up by putting energy into. Vaporization is going from a liquid to a gas. And remember, we have 2 examples for this: boiling and evaporation. You should know the difference between those 2. You have to put energy into, say, water to get it to boil. You have to put energy into water to get it to evaporate. And the last one is sublimation. And this is going straight from a solid to a gas. And our example for that is dry ice, solid carbon dioxide, creating fog, which is basically gaseous carbon dioxide. Then we'll have some lab questions. And actually, before I get to the lab questions, you should understand the heating curve. So we had 3 different pictures on the 4C PowerPoint. You had to draw it in your 4C homework, and then you created a heating curve, hopefully, when you did the boiling water lab. So you should understand that heating curve, what the plateaus mean on that heating curve. And that's basically the energy is used for the state change. And then the increases on the heating curve is the energy speeds up the particles. And remember, temperature is defined as average kinetic energy. Next, last, labs. Marshmallow lab. So, I guaranteed to you that you would have all those calculations that you did in the marshmallow lab on almost an entire page of this test. In your review homework, I have put a similar set of questions on the last couple of questions involving a Cheeto lab. So if you can understand how to do the Cheeto lab questions, you definitely can understand the Marshmallow Lab questions. And then last, the Boiling Water Lab. We added 2 new equations. Q, energy, equals mass times the heat of fusion. Remember, fusion is another word for melting. And then Q equals mass times HV, which is the heat of vaporization, and that is the boiling. So HF was given to you for that lab. We know what it is. I would give it to you on the test. It's for water. And then HV, same thing. So you'll have 2 or 3 questions, 4 questions, 4 questions involving these 2 equations on your review homework. And this would be, if you're looking at a heating curve, these would be the equations for the plateaus on a heating curve. Our regular equation, Q equals Cp times M times delta T. Would be used for the increases, to calculate the energy of the increases on a heating curve. All right, that is a full review for this test. You'll definitely need to study for this test. We'll take it on Thursday after we talk a little bit about those problems that you're about to do, and that's what you need to head on to next, is to doing the 11 or 12 review problems involving these equations and a mock Cheetos lab instead of a marshmallow lab. Hope you have a great election day, and I will talk to you all on Thursday. See you later.